Hi guys, in this video what we're going to do is we are going to look at the angle between two lines. So as you can see, if we draw two lines, what we have, for example, this line here and this line here, what we can work out here is this angle theta. And notice if this is theta and this is a straight line, this is obviously 180 degrees, take away theta because it is 180 degrees in a straight line. Notice as well that these are vertically opposite angles, theta, theta. And obviously this is 180 minus theta, 180 minus theta, those angles are the same. So if we have two lines, L1 and L2, and they both have a slope M1 and M2, and theta is in between those lines, you can see here, so L1, L2, there's your theta. Then we say that tan theta is equal to plus or minus M1 minus M2, 1 plus M1, M2, where M1 and M2 are the slopes of the lines. Now you might also see this in a book as this, where it says tan theta is equal to the modulus of M1 minus M2 all over 1 plus M1 multiplied by M2. It's exactly the same thing. The whole idea of this plus minus means that we can use the modulus instead. In fact, we quite often do that. Okay, so let's have a look at an example on how this works. It says, on a map, the equation of two rows may be written as 2x plus y minus 5 is equal to 0, and x plus 5y minus 2 is equal to 0. At the crossroads, the signpost has two signs pointing directly along the two roads. Find the angle between these signs if it's greater than 90 but less than 180. So we're looking for the obtuse angle here, i.e. the larger angle. Okay, so the first thing we do is we write down the two equations. And the second equation here is x plus 5y minus 2 is equal to 0. Okay, so first of all we need to get the slope. And if you remember from earlier in the videos, if we call this ax plus by plus c is equal to 0, and do exactly the same here, ax plus by plus c is equal to 0, then we can quickly work out the gradient, because the gradient is given by m. Gradient is equal to minus a over b. So straight away we should be able to get the gradients for both of these lines. So the first one, m1 here, is equal to, and it's minus 2 over 1, which is obviously minus 2, and m2 here is equal to, it's minus 1 over 5, and we now have the two gradients. Okay, we then just stick everything into the formula. So I'm going to use this formula here, and the positive answer of this will give me the smaller angle. So if I want the larger angle, I need to take it away from 180, but this will give me, the positive will always give me the smaller angle. So we have tan theta is equal to m1, which is minus 2, minus, and we've got m2, which is minus 1/5, so that double negative is going to make a positive, all over 1 plus m1, which is minus 2, multiplied by m2, which is minus 1/5. And we're going to modulise that so we can get the positive answer. If you stick that into your calculator on the right hand side there, you get tan theta is equal to, and it's come out to be minus 9 on the top, okay, over 7 on the bottom, and that's still to be modularised, which means that tan of theta, when we modulise that, remember the modulus is just taking the positive, is equal to 9 over 7. We can then work that out using our calculator, that theta is equal to tan, the minus 1, 9 over 7. Stick that into your calculator, guys, and you get an angle of 52.13. So theta is equal to 52.13. However, if you look, that's not what we were asked for. We were asked for the angle that's greater than 90 but less than 180. So that means that the angle we want, so the angle we need is 180 minus theta, which is equal to, obviously, 180 minus 52.13, and then it's going to be equal to 127.87 degrees, and we're finished. So it's just a case of sticking stuff in the formula. This is probably the easiest thing to do, is to use the modulus, work out everything in here. You can see we get minus 9 over 7 when we put this into our calculator. Find out what the positive one, which is the smaller angle. If we need the bigger angle, we just take it away from 180 as per the diagram there. Let's have a look at another example. So it says find the equations of the two lines through the point 1 minus 2, which makes an angle of tan to the negative 1 a half with the line 4x minus y plus 5 is equal to 0. Okay, the first thing we need to realise is it says find the equations of the two lines. We're looking for two equations of the line. It says through the point 1 minus 2, which makes angles of tan to the minus 1 of a half. Some of you might not know what that means. Tan to the minus 1 of a half. So if you think about it, theta is equal to tan to the minus 1 of a half. Okay, so which means that if we take tan on both sides, we to get rid of this tan to the minus 1 here, so we're going to tan both sides, we end up with this, just so you can see, we end up with tan theta on the left hand side is equal to tan to the minus 1 of a half on the right hand side. And you'll see that this tan and tan to the minus 1, that there is the inverse of this here, which means that these two things are going to disappear and we're going to be left with just half on the right hand side. So we end up with tan of theta is equal to a half, and we're going to need that for the formula. The next thing that might be useful is just do a quick sort of diagram about what's going on here. So it says that the two lines are going through the point 1 minus 2. So if we have 1 minus 2 here, and we've got angles with the line 4x minus y plus 5. So let's say 4x like that. Suppose this is our 4x minus y plus 5 is equal to 0. And what we're looking for is two lines that are going to make an angle of tan theta is equal to a half. So what we're going to have is something like this, 1, 2, where that there is angle theta, that there is angle theta. Those two angles are the same, but notice how there's going to be two different slopes for these lines. So this could be line 1 and line 2. It means we're going to get two different slopes, and there means we can get the two equations. We can find the equations of the lines straightforward. We have a point, and we need to find these two slopes now in order to find the equations of this line and this line. So you can see here, just go through the diagram again, point 1 minus 2. Then what we have is we have an equation of the line, 4x minus y plus 5 is equal to 0, and we're trying to make the same angle here and here, which happens to be tan theta is equal to a half. So you can see that we're going to have two slopes, two different slopes or two different gradients. Okay, so what can we do here? Well, we're going to do exactly what we did before. We're going to put it into the formula. Tan theta is equal to m1 minus m2 all over 1 plus m1 multiplied by m2, and we're going to use the plus or minus this time. Again, the modulus is exactly the same, just going to use the plus or minus. It's going to make this a little bit easier. Okay, now we already have the tan theta because we worked it out here when we said theta was equal to tan to the minus 1 of a half. We rearranged it and we ended up getting tan of theta was equal to a half. So straight away we know that tan theta is equal to a half, and that's equal to plus or minus, and again we've got m1 minus m2 all over 1 plus m1 m2. Now if we look at the diagram, you can see what we're trying to work out. It's trying to work out these angles here and here, and we have one of the lines, which is the black line. That's the 4x minus y plus 5 is equal to 0. I know the gradient of that. I can work that out. I'll do that in a second. And what we're trying to find out is we're trying to find out these two gradients or slopes where I've labelled it m1 and m2. So the first thing I'm going to do is work out the slope of this. Remember, we label it ax plus by plus c is equal to 0. The gradient m is given by minus a over b, which in this case is minus 4 over minus 1, which is equal to 4. And I'm going to stick that in as m2, so I'm going to stick it in for this one on my equation here. It can stick it in for m1 if I wish, it makes no difference. I'm just going to stick it for m2 just because it makes life a little bit easier. So I have a half is equal to plus or minus, I don't know what this m1 is, I'm just going to call it m because I'm going to end up with two answers for it. So m minus 4 all over 1 plus, and I'm going to end up with m1, which is just m, and I'm going to end up with m2, which is 4. So there you can see I've got a half is equal to plus or minus m minus 4 all over 1 plus 4m. So there's two cases for this now. I've either got a half is equal to plus m minus 4 over 1 plus 4m, or the second case, which is a half is equal to minus m minus 4 all over 1 plus 4m. Okay, so there's the two different gradients that I'm going to get. So we'll do the first one first. If I do that, I'm going to cross multiply. So I'm going to cross multiply this to get up here, this to get up there, which means I'm going to end up with 1 plus 4m is equal to 2m minus 4. I'm going to multiply out that bracket, get 1 plus 4m is equal to 2m minus 8. I'm going to take the m's across from here to here. I'm going to take that across to there. Okay, and if I do that, I'm going to end up with 2m on this side is equal to minus 8 minus 1, which is minus 9, and m is equal to minus 9 over 2. Okay, for this one here then, on the right hand side, I'm going to multiply again, cross multiply this up, and do exactly the same thing. So I'm going to end up with 1 plus 4m is equal to minus 2m minus 4. I'm going to multiply it out again like I did before. So I'm going to end up with 1 plus 4m is equal to minus 2m plus 8. Again, I'm going to take this across to this side, this across to this side. So I'm going to end up with 4m plus 2m, which is 6m, is equal to 7, and m is equal to 7 over 6. I'm not quite finished because it doesn't ask me for the gradients or the slope. It asks me for, it says the equation of two lines. So in the previous slides we've used y minus y1 is equal to mx minus x1, and we're going to use that just to finish this off for this one and do exactly the same with the other m on the other side. Notice that they're both going through 1 minus 2 here. You can see that they both go through that line, and we're told the equation of the line is going through the point 1 minus 2. So all we do is we put in the numbers that we have. So in this case we have y minus y1, which is minus 2, is equal to m, which is minus 9 over 2, and then we have x minus 1. Okay, so we've got y plus 2 is equal to minus 9 over 2, x minus 1. And I'll just move this up so we can finish this particular thing off. So I'm just going to move that slightly up so I can finish this off. So what we're going to do then is times everything by 2. So we're going to get 2y plus 4 on this side. So 2y plus 4 is equal to minus 9 x minus 1. Okay, then I'm going to multiply out the bracket. So I get 2y plus 4 is equal to minus 9x plus 9, and I'm going to take everything across the left hand side to get 9x, and then we've got plus 2y, 4 minus 9 is minus 5, is equal to 0, and that there is your equation of your line. I'm going to do exactly the same now with this one up here. Okay, so this one up here, instead of using the minus 9 over 2, I'm just going to put 7 over 6 and do exactly the same sort of math. So what we end up here is y minus 2, which we now know is plus 2, is equal to m, which is 7 over 6, and it's going to be x minus 1. Okay, so all I've done there is put in the numbers again. Okay, you see the y plus 2 is going to be the same here, is equal to mx minus the 1 here. Okay, I'm going to multiply everything by 6 to get 6y plus 12 is equal to 7x minus 7. Okay, so I've done two things there. What I've done is I've taken that across, multiplied that. 6 by y is 6y, 6 by 2 is 12, and I've multiplied out on the right hand side 7 by x, 7x, 7 by minus 1 is minus 7, and I'm going to collect everything on the right hand side this time because I just like to have my x's positive when I do the equation of the line. So what we have here is 7x minus 6y, and we have minus 7 minus 12, which is minus 19, is equal to 0, and that there is the second equation of my line.